Multivariable calculus. We're in lesson 15.2, our second video, our part 2 video. We're finishing up example 4. We were told to find this volume. So in other words, as the planes are cutting off x equals 2 and y equals 2, and the three coordinate planes, if we go from x equals 0, y equals 0, and even from z equals 0, which would be the xy plane, what that really is going to create for us on the xy plane would be this rectangular region between 0 and 2. In other words, x would be contained between 0 and 2. Likewise, y would be contained between 0 and 2. So the three coordinate planes would, indicate that x equals 0, y equals 0, and z equals 0. It's more or less saying you're going to be in this first, what we call octant. You've heard of the first quadrant. In 3D, this would be the first octant. And as we work this out, of course, it really doesn't matter what order we're going to go here. If you look at your integrand, I think you can see rather quickly that, taking an antiderivative with respect to x or y really isn't going to be more easy in one variable rather than another. So let's just go ahead and integrate with respect to x first, and realize also that your 2y squared is seen as a constant, of course. And as we continue with the fundamental theorem here, this would be 16 times 2, which is going to be a 32. This is 2 cubed, which is an 8 all over a 3. And then we'd have 2y squared times a 2. But when you plug in your x values of 0, of course, you're going to see every term there collapses. So this is going to be a 32 minus 8 thirds minus a 4y squared. And 32, if we get a common denominator over 3, that's 96 over 3. 96 minus 8 is going to be 88. So as we combine those two, that's 88 thirds minus a 4y squared. And guys, here we go again. At this point, thankfully, this is a problem from Calc BC, and in fact, the easiest early part of it, learning how to do fundamental theorem problems. Integrate with respect to y would get 88 thirds y. Bump this up to a 3, you'd have 4y cubed all over a 3. When we plug in our 2, we'd get 88 over 3 times a 2 minus 4 times 2 cubed all over 3. The 0 part, I hope, is easy. That wipes everything out. This becomes, let's see, I think that's 176 all over a 3. 2 cubed is 8. 8 times 4 is 32. And 176 minus 32, I believe that's 144. But 144 is 12 times 12. And if you think about that, you're going to be able to divide by 3. Couple of different ways you could look at it. 3 would go into this 12 4 times. 4 times 12 is 48. So that would be the volume of that elliptic paraboloid over the rectangular region from 0 to 2 for both x and y. This next theorem, wow, what a wonderful, wonderful shortcut it is. Please pay attention. This is only applicable when you have a multiplication of two functions and they are independent of each other. In other words, you have a function just with respect to x multiplied to a function just with respect to y. If that's the case, and you've got your x values, bounded between a and b, you've got your y values bounded between c and d, you could just integrate g of x with respect to x on those x boundaries, multiply it to the integral from c to d of h of y dy. So that's a wonderful, fantastic application of what can happen here. So take a look. You'd see sine of x right here, cosine of y. You're going to see very quickly that those are, in fact, very different functions, independent of one another. Look, if we were integrating with respect to x first here, honestly, it doesn't matter which way we go. You can see, well, wow, sine of x and cosine of y, they are separate. Look, I'm just going to turn this into the sine of x dx, integrating in these boundaries from 0 to pi over 2. And then we're going to say, look, we'll go from 0 to pi over 2, also the y boundaries of the cosine of y dy. Right now, this becomes really just a Calc BC problem where you work those two parts out separately and multiply them together. Antiderivative of sine is negative cosine, and we'll evaluate that between pi over 2 and 0. Cosine of pi over 2 minus the cosine of 0. Well, cosine of pi over 2 is 0. This is a 1. A negative times a negative, well, that's just a positive 1. Likewise, if we come over here, antiderivative of cosine is just a sine. And then fundamental theorem, we'd say, well, that's the sine of pi over 2 minus the sine of 0. Well, sine of 0 is 0. Sine of pi over 2 is 1. So final answer is 1 times 1, which is just a 1. Now, please understand, you don't have to use this theorem. If you would have just integrated with respect to y or x first, keeping the other function as a constant, of course you'd get the same answer. But this is such a nice, easier setup. Whenever you can take advantage, strongly recommend that you do.